Hi everyone. Boy, didn't see this coming last time I spoke to you. Lots has changed since then. I hope you're all well. I hope your families, your friends, and acquaintances are all well, both mentally and physically. I think it's going to be a really tough couple of months from now on. Um, I hope that we don't add to any of your stress in Gen Chem. We're trying to make this as easy and smooth as possible. No one in our group has taught online before, and I haven't even taken an online class. So this is going to be a little awkward, I think. I'm going to try my best to make this as easy as possible. All your lab instructors, recitations instructors, and I are all at home. We aren't having any secret titration parties or anything like that. But we're all in contact, trying to make this as easy as possible. So let me tell you a little bit about how I envision to running the course from now on. Okay, so let's talk a little bit about the class. The class will be held in two formats. One is I'll use classes from the MIT lectures, such as the one shown on the left here, and I'll put them up on the web, and you'll be expected to listen to them um, before or on the day of the class. The other is I'll make some PowerPoints, animated PowerPoints like this one that you're seeing right now, in cases where I prefer to have some of my own content rather than the MIT content. So you'll have one or two. Okay, let's talk a little bit about grades. Um, it's going to be really difficult to have tests or finals in this online format, so we're not having any tests or finals. Instead, we'll rely a bit more on SmartWorks. You'll be getting a steady stream of SmartWork problems that are related to the classes that we'll be presenting. The SmartWorks will be on a code basis, so you really have to do these by yourself. You can't ask an older brother who's taken chemistry, or a sister, or your parents, or even the internet. You can certainly ask people to help you with how to do the problems, but not show you how to do that specific problem. So we'll have a whole bunch of SmartWorks that will take the place of the final and the test. That might be a little scary to some of you, but I guess probably the best news is the faculty voted on Friday that will allow the satisfactory, unsatisfactory option. So if you want to take this course in this option, basically you just tell the registrar, and then if you get anything above a D minus, you get an S grade. If you get below a D minus, it's unsatisfactory. You should be getting an email probably from your dean explaining how this works. So that's what we have about the grades. I think it's really important that you interact with somebody on the general chemistry team. So we're going to have recitations. These recitations will be held on Wednesdays. I'll send out a doodle poll. On the doodle poll, show me all the times that you can do. What we're going to do, there are 5 of us that can do these recitations. We'll all have 2 hours on Wednesday. And so you can choose an hour, and I'll try and spread them out throughout the whole day so that you can find a time that works for you. Once you've chosen that time, say Wednesday noon Eastern time, that's your recitation time for the rest of the semester. You could also choose one at 9 at night Eastern time. I'll put up a whole bunch of different times. In the recitations, we'll go over problems that are similar to the smart work problems and try and help you out, very similar to the recitations we had before. These recitations will have about 10 students in each of them. They'll be held on WebEx. Labs are obviously going to be the hardest. It's going to be very difficult to do virtual labs, especially since we've got no experience in this. So what we'll do next week is we'll take some data from previous years, send you the data, send you the instructions for the lab, and a Word document that you then need to fill out using the data, which is data for an acid-base titration. You have to draw and plot the pH as the function of the acid or base added. From that, then you have to work out the Ka and the pKa. So, but you'll see that when you get the lab. We'll have a few less labs than we would have had, just because it's going to be pretty difficult to do that. So, hi, you know how hard I find it to avoid talking about applications of chemistry, and even here I'm going to slip one in, and that's the test for the coronavirus. Here's the coronavirus. This is the little bugger that's causing all the problems we have right now. It's basically a ball, a capsule. Inside the capsule is RNA. The RNA is like the recipe book. It sneaks this recipe book into our cells. The cells think it's RNA that belongs to the body, incorporate it into its DNA, then change it to DNA. And so now we've got the virus recipe inside our own DNA, and our body then copies it and makes many, many, many more of these viruses. So how do we test for an infection? Well, at the moment, this is how the test works. You take a swab, you stick it deep up somebody's nose and throat. You get all the mucus there and hope that in the mucus, if the person has an infection, there's a virus. In the virus is the RNA. The RNA is extracted from here, so you get this RNA out from here. And then you use an enzyme. Remember, an enzyme is a protein that catalyzes a reaction. In this case, the reaction is making DNA from the RNA. So you add another strand to this RNA that's opposite to the RNA you have, and you get yourself a DNA strand. Now you've got the recipe book of the virus. You then go and multiply this, use PCR, polymerase chain reaction. So you make millions and billions of copies of this, and only of this DNA. So it'll only copy DNA that's found in the coronavirus, no other DNA. So even though here there's obviously mucus and snot contains your own cells, it's not going to copy them because they aren't viral coronavirus DNA. So it only copies the coronavirus DNA. So the only DNA that's copied is DNA from the virus. You can't see it at this point, so you add a fluorescent dye. The fluorescent dye binds to the DNA, and since the DNA is viral DNA, the amount of fluorescence you get corresponds to the amount of DNA or viral RNA in the beginning you had from your coronavirus. So what happens is you copy the DNA, copy the DNA, copy the DNA, and look for fluorescence. If there's fluorescence past a certain threshold, that's a positive. If there's no fluorescence, that means there was no DNA. That means there was no viral RNA, which means there was no virus, and so that's negative. There's some problems. Strangely enough, even though this is a reaction that's done in labs everywhere, research labs and everything, we don't have enough of these reagents. It takes quite a few hours to do each test because you've got to wait for everything to multiply and do that. And you also sometimes get false positive. Also, what this test tells you is that you've got a viral RNA in your nose. It doesn't tell you whether you had an infection 5 or 10 days ago. So you might no longer have the viral RNA in your mucus because you've now got over the sickness. So we can't see that. In the future, what we want to be able to do is look for antibodies, which will then tell us, oh, your body's detected these coronaviruses and wants to get rid of them. So that's just a little bit about the chemistry of how coronavirus works.